Hello, biology and AP environmental science. The purpose of this video is to give you an opportunity to practice a little bit with scientific notation. AP environmental science, you probably will see very little, if any, scientific notation. It's possible you might see it on a free response question, either practice or on the actual AP test. So it's less important that you have an understanding of this than my bio kids. But please play along. It's a good review. I'm sure you got plenty of practice with this in chemistry. All right, assuming you took chemistry, some of you may have taken physics. All right, without further ado, so this looks very similar to the handout that you should have. I've just made a slight modification. I've added the exponent here. So what we're going to do is we're going to convert 5 of normal notation numbers into scientific notation, and then we will convert scientific notation into normal notation. All right, here we go. So let's see. Biology, you actually took notes on scientific notation, so you're probably familiar with the fact that if it is a large number, you're probably going to have you're definitely going to have a positive exponent, whereas if it is a small number, you're going to have a negative exponent. And the exponent's value is how many places the decimal will need to move to get back to the normal notation number. Same down here, negative exponent. So this is going to get smaller, positive exponent. So this is going to get bigger. Because this is a video, we'll have an opportunity for the sub to pause the video for a few seconds to give you an opportunity to write down what your supposed answer is. Or if you're really good at this, you can bang them all out and finish them early and then just simply watch the video to check your answers. Okay, so scientific notation, the decimal always goes after the first whole number. So what I'm going to do is I'm just going to enter all the numbers, 4, 5, 8, 7, 1, 6, 2. Decimal always goes after the first whole number. Now, for this to get back to what it originally was, the decimal has to go to the right, which means that my exponent's going to be positive, and it needs to go 1, 2, 3, 4, 5, 6 spaces. Therefore, my exponent is a positive 6. The larger your positive exponent, the larger the normal notation number is. The larger the negative exponent, the smaller the normal notation number is, meaning more decimal places and potentially zeros after the decimal. Okay, let's see. I'm going to write all the numbers 3, 1, 8, 9, 4, 2. Decimal always goes after the first one. And if it's here, it's got to go 2 spaces to the right. Right means it's positive. 2 spaces means it's positive 2. All right, next one. Oh, so it's already in scientific notation format with a decimal. So 4, 3, 2, 8, 7. The reason why it says careful with the exponent is because to make this equal to the normal notation number, we have to multiply it by 1, and 10 to the 0 is equivalent to 1. All right, so this is kind of a tricky one. All right, let's see. I'm going to write down all the numbers, 2, 3, 8, 8. Decimal's always going to go after the first one. Okay, so if the decimal needs to go to the left to get back to where it was, that's going to be 1, 2, 3 spaces to the left. Left means it's minus. And the 3 means 3 spaces to the left. All right, 1, 8, 3, 3, 4, 8, 3, 7. Decimal's always after the first one. All right, so if this is where the decimal is, it goes 1, 2, 3, 4, 5 spaces to the right. That makes it a positive exponent, and it makes it a positive 5. All right, on to the reverse. All right, we're going to use the same logic. Negative exponent means the decimal's going to the left. Value of the negative exponent indicates how many spaces to the left. Positive exponent means the decimal's going to the right. Value of the positive exponent indicates how many spaces to the right. So I'd like to do the exact same thing. 1, 6, 2, 3, 8. Negative 4 means it's going to go 1, 2, 3, 4. So that means I need a decimal 1, 2, 3. All right. So again, if it was here, 1, 2, 3, 4 spaces to the left, that is what the -4 gives you. I tend to like to put zeros in front of the decimal just to remind myself that we're talking about a number with a decimal place and not a period, especially if a number was included in, say, a conclusion of a lab report, but it's not necessary. All right, let's see. 7, 4, 8, 3, 6. 7. Whoa, that's not what I meant to enter. 7, 4, 8, 3, 6. All right, so the decimal's a +2, which means it's going 2 places to the right. 1, 2. All right, next one. 4, 9, 7, 4, 8, 3, 2. I have a -2 exponent, which means it's going to the left. It's going to go 1, 2 spaces to the left, so that means I have to add 1, 0. Again, 1, 2. I should have 1, 0 in front of the 4, and I do. +5 means it's going to the right, and it's going to the right 5 spaces. 1, 2, 3, 4, 5. Don't need to do this, but that'll remind me where the decimal place actually belongs. +8, holy moly, if it's a +8 or a +5, we're probably talking about a large normal notation number. 7, 1, 8, 4, 9. All right, so 1, 2, 3, 4 spaces, and I need 4 more spaces. 1, 2, 3, 4. And again, I always like to add a 0.0 to remind myself where the exponent is. All right, y'all. Hopefully, I didn't make any mistakes. It happens on occasion. And hopefully, this gave you an opportunity to become once again familiar with converting to the scientific notation or converting back to normal notation, or to get some practice learning it the first time. All right, y'all. I will see you when I see you.